So here's the lab setup that we're going to use to experiment with voltage division. This setup has three main components. There's the voltage divider over here on the left, which is really coming directly from a potentiometer. There's a voltage divider that comes from this photocell and a resistor that's in series. And then over here is the third component. This is a comparator circuit. Now when you arrive at lab, it'll probably be pre-wired up in a configuration a lot like this. There's still some test leads that you're going to need to connect, but most of this wiring will have already been done. Now what I've got here is the digital multimeter here is set to the 20 volt range, and then I have each of the two leads connected with an alligator cable to these two wires right here. So I can permanently leave the ground connection directly connected to the ground of the board, and then I can move the other lead around to various places, keeping my hands free so I don't need to worry about holding on to them. So I think this is the best way to use the multimeter, is to use the alligator cable and connect it to these test leads. So right now I have it connected to the power supply. I'll go ahead and turn the power supply on, and you'll see that it jumps up to about 9 volts. Again, plus or minus a few hundredths, there's no problem there. Now what we've done here is we've taken this potentiometer involving the photocell and the resistor. We've chosen the value of that resistor such that the voltage in the middle here should be at about halfway between 0 volts and 9 volts. You can see here it's at about 3.5. Depending on the light level, it could be a little bit higher. Right now my office is not quite as bright, I think, as the lab is, but if I bring in a little handheld flashlight here, you'll see that voltage is going to jump quite a bit up. So if I put the flashlight right down there, you'll see that it gets higher and higher. Obviously the upper limit is going to be 9 volts, but we can get really, really close to grabbing all of the 9 volts. Or if I take it away, you can see that it's back down to about 3.5 volts. Or if I put my hand over it, you'll see that it'll go even lower, down to about 0.4 volts. Or if I put my finger directly on top of the sensor, we're down perhaps about as low as we can get, down to about 0.4, 0.5, something like that volts. So we can see that there's going to be a wide dynamic range. About 0.3 volts, it's 0.2. 2.5. That's about the best that we can do. So we have a wide dynamic range here of more than a factor of 10. So that's going to be one of our voltage dividers. And realize that the voltage we're measuring in the middle here is changing because the resistance of this sensor right here is changing. And as that resistance changes, more or less of the voltage appears across the other resistor. Now the other voltage divider that's here is just being caused by one device. You'll see that this device right here, the potentiometer, is connected to plus 5 volts on one side, and it's connected to ground on the other side. This device actually has 3 leads. So if I pop it out and bring it up here, you can see the 3 leads, and the 2 outermost leads are connected to plus 5 volts and to 0 volts. I'm sorry, plus 9 volts and to 0 volts. If I put it back in, that middle terminal is going to be at varying voltages dependent on how I turn this knob. So if you watch the multimeter there, you can see that it's going up, up, up. What I'm doing is I'm changing how much of the resistance is above that middle terminal. So the middle terminal is moving up and down sort of the range from 0 ohms up to about 1 kilo ohm. And as I'm moving this back and forth, we can see that voltage is going to adjust up and down as well. So what I'd like to do is I'd like to first of all remind myself what was the sort of ambient light voltage here. We were at about 3.5 volts. What I'd like to do, but remember that when I cover this, it goes down. What I'd like to do is I'd like to put this voltage, this one right here, a little bit lower than 3.5 volts. Let's say I'd put it at about 2.5 volts. So I'm going to adjust this knob until it's at about 2.5 volts. Once I get, it doesn't have to be exact. This is approximate here. So once I get to around 2.5 volts, now I can go ahead and pull this out. So things that I know that the power is at 9 volts. I know that this voltage right here is going to be between the photocell and the resistor. It's going to be at about 3.5 volts in my office here with the amount of light that I have. But as I cover it, the voltage is going to go down. And I know that this voltage over here is at about 3.5 volts as well. Now I'm going to take these two terminals, I'm going to take these two leads right here, and I'm going to attach the photoresistor to pin 2 of this chip. Now this is a comparator chip, and pin 2 is going to be one of the 2 inputs. Now don't pay any attention to the LED yet, because it isn't fair until both have been connected. I'm going to attach the potentiometer to pin 3. Okay, now both of them are now connected, and you can see that what the comparator is saying is, oh, there's really nothing to be seen here. There's nothing interesting. I'll go ahead and zoom in because this is now the most important part of the circuit. So you can see we have one voltage divider through the yellow wire is going to pin 3. The other voltage divider through the green wire is going to pin 2. But the interesting thing is that when I cover this up, the LED lights. So what happens is that as the voltage of the photocell, as the voltage of this voltage divider decreases, it passes so that it's lower than the one that's coming from the yellow wire. And the job of the potentiometer then is to identify when the green wire is lower than the yellow wire, or when the yellow wire is higher than the green wire. And when that happens, it's going to deliver a voltage that can be used to light this LED. Now you'll notice that the LED still has the current limiting resistor here. So that current limiting resistor is going through the LED and to pin 7 of the comparator. Pins 1 and 4 of the comparator need to be tied low. Pin 8 needs to be tied high to give it a voltage supply. Let's see, it looks like pin 7 is the output, and it looks like pins 5 and 6 are not being used in this configuration. So what we have here is we have the ability to light an LED when the light level drops below a certain point. So you can imagine this would be like a night light. This would be like an automatic night light. When it gets dark, you're gonna light the LED. One thing that you might want to think about, and what I'd like you to think about, is how could you adjust this circuit in a very slight way such that the LED would light when the light level is high enough. So in other words, instead of being off and then on, it would be on and then off. And so this would be more of like a light sensor. It would say that as long as the light is bright enough, I'm going to turn on the LED. When the light gets lower, I'm going to turn off the LED.